period. This is the value of c in the graphs y equals a plus b sine of cx and y equals a plus b cos of cx. So the c value that's stuck on in front of the x. Note that we only need to consider values of c greater than 0. This is because of the negative angle results from chapter 14. So we know that cos of minus a is really cos of a, and sine of minus a is really minus sine of a. Thus, for example, we can write y equals 2 plus 3 sine of minus 4x as y equals 2 minus 3 sine of 4x. So we bring the minus in front of the 3. Just like we would bring the minus in front of the sine. Or for an example using cos, y equals 4 plus cos of minus 3x is going to give us y equals 4 plus cos of 3x. So we just make the minus into a positive. Just like cos of minus a becomes cos of a. So this is the rule. The period of y equals a plus b sine of cx, or y equals a plus b cos of cx, where c is greater than 0, is 360 degrees divided by c if we're in degrees, or 2 pi divided by c if we're in radians. So the transformation, the value of c greater than 0 depends on the horizontal dilation, which means the stretch or shrink about the y-axis. The curves y equals sine of x and y equals cos of x are shrunk by a factor of c, which means stretched by a factor of 1 over root c. So the inverse. When forming the curves y equals a plus b sine of cx and y equals a plus b cos of cx, respectively. So we can say that the graphs are shrunk by a factor of c. So whatever that number is stuck on in front of the x, they're shrunk by a factor of that number. Or you could say they're stretched by a factor of the reciprocal of that number, 1 over c. So the diagram below shows curves y equals sine of x and y equals sine of 2x for x values between 0 and 2 pi. This can easily be verified by making a table of values. From the graph, it can be seen that the period of y equals sine of 2x is 2 pi divided by 2, which is pi, or 180 degrees. So this curve that I've just highlighted in yellow is the graph of y equals sine of x. And the curve I've just highlighted in green is the graph of y equals sine of 2x. So we can see that one period of y equals sine of x goes from 0 to 2 pi, or 360 degrees, whereas one period of y equals sine of 2x goes from 0 to pi, or else 180 degrees. And then it gets repeated again for another 180 degrees. So in the top graph, the red curve is y equals sine of x, and the blue curve is y equals sine of 2x. In the second graph, the red curve is y equals sine of x, and the blue curve is y equals sine of 3x. And in the last graph, the red curve again is y equals sine of x, and the blue curve is y equals sine of 4x. So we can see that as the number in front of the x gets bigger, so we had 2, then we had 3, then we get 4, the graph is getting squashed closer and closer together, and the period of the graph is getting less and less. So again, with our top graph, one period of the graph of sine x in red goes from 0 to 2 pi, or 360 degrees, and one period of the graph of y equals sine of 2x goes from 0 to pi, or 180 degrees. So we can see that the period is getting smaller each time. Likewise, we can see the same thing happening with cos of x. So on the top graph, our red curve is y equals cos of x, and our blue curve is y equals cos of 2x. In our second graph, the red curve again is y equals cos of x, and the blue curve is y equals cos of 3x. And in the last graph, the red curve again is y equals cos of x, and the blue curve is y equals cos of 4x. To explain why the period of y equals sine of 2x is 2 pi over 2, which equals pi, notice that the curve begins to repeat itself once the angle reaches 2 pi. So if we have a look at our graph on top, so the blue curve is y equals sine of x, and the red curve is y equals sine of 2x. So we can see that with the blue graph, y equals sine of x, if we start at 0 and go up as far as 2 pi, we get one period of the graph of y equals sine of x, or one building block. So if the angle is 2x, then this will be when 2x is equal to 2 pi, i.e. x is equal to pi. So we can cancel out the 2's and we're left with x is equal to pi. In general, the graph of y equals a plus b sine of cx, or y equals a plus b cos of cx, will begin to repeat itself when the angle is 2 pi, or 360 degrees. In each case, this will be when cx is equal to 2 pi, i.e. x is equal to 2 pi divided by c. So this is the period of each function. So for example, if we have y equals sine of 3x, we're going to let the 3x equal to 2 pi and solve for x. So we're going to divide across by 3, so we get x equal to 2 pi over 3. So the period for y equals sine of 3x is 2 pi over 3. If we have the graph y equals sine of 4x, we let the 4x equal 2 pi, we solve for x, we get x equals 2 pi over 4, and 2 pi over 4 will simplify to a half pi. So if we have the graph of y equals sine of 4x, the period for that graph is going to be pi over 2, or a half pi. If we have y equals sine of a half x, or sine of x over 2, we let the half x equal 2 pi, and we solve for x, so we end up with x equals 2 pi divided by a half, which is really 2 pi over 1 multiplied by 2 over 1, which gives us 4 pi. So the period for the graph of y equals sine of a half x, or y equals sine of x over 2, is 4 pi. So the top here in blue, we have the graph of y equals cos of x. And in red, we have the graph of y equals cos of 2x. So we notice that the same thing is happening. So if we want to find the period for the cos function, we do the exact same thing. So for example, y equals cos of 2x. We let the 2x equal 2 pi and we solve for x. We get x equals 2 pi over 2, which is pi. So the period for the function of y equals cos of 2x is going to be pi. If we have the graph y equals cos of 6x, we let the 6x equals 2 pi and we solve for x. We get x equals 2 pi over 6, which is a third. So the period for the graph of y equals cos of 6x is going to be pi over 3. And if we have the graph of y equals cos of a quarter x, or y equals cos of x over 4, we let a quarter x equal 2 pi, and we solve for x. So we get x is equal to 2 pi divided by a quarter, which is 2 pi over 1 multiplied by 4 over 1. So we end up with 8 pi. So the period for the graph of y equals cos of a quarter x, or x over 4, is 8 pi. So to summarise, whatever number is stuck on in front of the x, for whether it's sine or cos, whatever is in place of the c, we let the cx equal to 2 pi, and then we solve for x. So basically we just divide by the number that is stuck on in front of the x. We divide 2 pi by that number, and that will give us the period.